Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 Higher Tier from 2022. Question number 5 is on the topic of waves. A student investigated how the color of a surface affects the amount of infrared radiation the surface absorbs. This is actually a required practical question. Figure 7 shows the equipment used. The two flasks are painted different colors. So you've got a black flask, which is a round bottom flask, and a white flask, which is a conical flask. So this is a round bottom. And this is a conical flask. So you have the infrared ramp and a timer. This is the method used. Pour water at 20 degrees into each flask. Place a bung and thermometer into each flask. Place each flask in front of the infrared lamp. Measure the temperature of the water every 30 seconds for 10 minutes. Explain 2 improvements to the method the student could use. So instead of keeping 2 different flasks of different shapes, it will be better to keep the same shape. It doesn't matter which one, because each shape would actually hold different volumes of water, and the surface area that is exposed to the infrared can actually change. And also they haven't mentioned about the distance as well, so you want to keep the same distance for both the flasks. It looks like the white flask is actually closer than the black flask, because the radiation, infrared radiation, is higher near the lamp than further away. So here's the answer. Place each flask the same distance from the infrared lamp. So, because remember, it's a 4-mark question. Explain, you have to explain why you're doing it. So the intensity of infrared radiation incident on each flask is the same. You don't have to use the word incident, as long as you say the intensity of the infrared radiation received by each flask is the same. Use flasks of the same shape and size, so the surface area is the same. And third point you could do is use equal volumes of water, because volume of water affects the rate at which the water temperature increases. If you have more water, it takes more time to heat up. Figure 8 shows the results for each flask. So you've got the black flask, they're both starting at 20, as they said. Black flask has gone up to 56 degrees Celsius. The white one has gone up to 27 degrees Celsius. Complete the sentence. After 100 seconds, the temperature difference between the black flask and the white flask was. So at 100, the white flask is 26 and the black flask is 31.5. So 31.5 minus 26, that's 7.5. So the difference is 7.5 degrees. The temperature of the white flask stopped increasing. The temperature inside the black flask continued to increase for a further how many seconds? So when did the white flask stop? You could say, let's say it at 200. And this one is reaching up to there, which is 440. So the difference is 240 seconds. The initial rate of absorption of infrared radiation by the black flask was greater than the initial rate of absorption by the white flask. How does figure 8 show this? So initially, as you can see, the line for the black flask is much steeper than the white flask. So you could say that the gradient is actually higher. So the black flask line has a greater gradient, or you could say the temperature of the black flask increased more during the same time. Explain why the temperature of the water in the flask increased and then became constant. Well, initially, they're absorbing the temperature infrared radiation. As they absorb, they were also going to emit radiation as well into the surroundings. So when the temperature increases, the rate of absorption also increases. So does the rate of emission. Eventually, when both of these equal each other, then they flatline, and they usually flatline around the room temperature. So here's this answer. The flask absorbs infrared radiation and transfer energy to the surroundings by heating and emission of infrared radiation again. Initially, the rate of absorption of infrared is greater than the rate of energy transfer to the surrounding, causing the temperature to increase. The rate of energy transfer to the surrounding increases as the temperature of the flask increases. Eventually, the rate of energy transfer to the surrounding is equal to the rate of energy transfer to the flask, causing the temperature to become constant. That brings us to the end of question number 5, and I will see you in question number 6.